Welcome to our new video on Science, Space, and Technology YouTube channel. This is gonna blow your mind. In our previous video, we delved into the basics of quantum mechanics and its implications. Today we take a closer look at the very building blocks of matter, atoms, and their subatomic particles. Atoms are the fundamental building blocks of everything we see and interact with. They form the basis of all matter, from the air we breathe to the stars in the sky. Every object, living or non-living, is composed of these tiny units. They are incredibly small, yet they contain even tinier particles within them. To put it into perspective, a single strand of human hair is about 1 million carbon atoms wide. Despite their minuscule size, atoms are complex structures with a rich internal architecture. At the heart of every atom lies the nucleus, a dense core packed with protons and neutrons. This nucleus is incredibly small compared to the overall size of the atom, yet it contains nearly all of the atom's mass. Protons carry a positive electrical charge, while neutrons have no charge, making them electrically neutral. The number of protons in the nucleus not only defines the element but also influences the atom's chemical properties. These two particles, similar in mass, give the atom its weight. The mass of an atom is primarily determined by the combined number of protons and neutrons in its nucleus, known as the atomic mass number. Orbiting the nucleus is a cloud of electrons, much lighter particles carrying a negative electrical charge. These electrons move in regions called orbitals, which are defined by complex mathematical equations. The number of protons, known as the atomic number, determines the type of atom. This atomic number is unique to each element and is what organizes the elements in the periodic table. For example, an atom with 1 proton is hydrogen, the simplest and most abundant element in the universe, while an atom with 8 protons is oxygen, a vital element for life on Earth. The arrangement of electrons in their orbits dictates how atoms interact with each other, forming the basis of chemical bonds and the vast diversity of matter we observe. These interactions lead to the formation of molecules and compounds, which are the building blocks of all substances. The balance between the positively charged protons in the nucleus and the negatively charged electrons orbiting it keeps the atom electrically neutral overall. This neutrality is essential for the stability of atoms and the formation of stable matter. This delicate balance of forces within the atom is crucial for the stability of matter as we know it. The strong nuclear force binds protons and neutrons together in the nucleus, while the electromagnetic force keeps electrons in their orbitals. Understanding the properties and interactions of these subatomic particles is key to unraveling the mysteries of the universe at its most fundamental level. Scientists continue to explore the atomic world, seeking to unlock the secrets of matter and energy, which could lead to groundbreaking discoveries and advancements in technology. Venturing deeper into the atom, we enter the strange and counterintuitive realm of quantum mechanics. Here, the classical laws of physics we observe in our everyday lives no longer hold sway. Instead, we find ourselves in a world where the rules are vastly different and often defy our intuition. Particles like electrons cease to behave like tiny billiard balls with predictable trajectories. Instead, they exhibit a perplexing duality, acting like both particles and waves simultaneously. This duality is not just a theoretical concept but has been demonstrated through numerous experiments. This wave-particle duality is one of the most mind-bending concepts in quantum mechanics. Imagine a beam of light, which we typically think of as a wave. When we shine this light through a narrow slit, it creates a diffraction pattern, a hallmark of wave behavior. However, this same beam can act like a stream of particles called photons, each carrying a specific amount of energy. These photons can be detected individually, as if they were tiny bullets hitting a target. Conversely, electrons, which we often think of as particles, can exhibit wave-like properties, such as diffraction and interference. When electrons pass through a double-slit apparatus, they create an interference pattern, just like waves do. Adding to this strangeness is Heisenberg's uncertainty principle, which states that we cannot know both the position and momentum of a particle with perfect accuracy at the same time. This principle is not just a statement about the limitations of our measurement tools, but a fundamental property of nature. The more precisely we try to pinpoint one property, the more uncertain the other becomes. For instance, if we measure an electron's position very accurately, its momentum becomes highly uncertain, and vice versa. This isn't a limitation of our measurement tools but a fundamental property of the quantum world. It suggests that at the smallest scales, the universe operates in a way that is fundamentally different from our everyday experiences. The uncertainty principle implies that at subatomic scales, the universe is inherently probabilistic. We can no longer speak of particles having definite positions and velocities, but must instead talk about probabilities. We can only predict the probability of finding a particle in a particular location, not its exact position. This probabilistic nature is a core aspect of quantum mechanics and challenges our classical notions of determinism. This inherent uncertainty is a defining feature of the quantum world and has profound implications for our understanding of the universe at its most fundamental level. It forces us to rethink our concepts of reality and causality. As we continue to explore the quantum realm, we uncover more about the strange and fascinating behaviors of particles. These discoveries not only deepen our understanding of the universe but also pave the way for new technologies and innovations that could transform our world.